consolidation video on inequalities. So we'll start with linear inequalities, like 6 minus 2x is greater than 1. Now, we can solve it just like an equation to start off with. And so if I want to, I can move the plus 6 that's over here to the right-hand side, and it will become minus 6. And that will leave me with minus 2x here. I've got rid of the plus 6, and it becomes minus 6 over here, is greater than 1 minus 6. So minus 2x is greater than minus 5. However, we need to be very careful if we multiply or divide by a negative number, because what happens then is that the inequality swaps direction. So here I'm going to divide by minus 2. Well, minus 5 divided by minus 2, the minus signs cancel and we're left with 5 over 2, or 2.5 if you wanted. And the x stays there. But notice the inequality swaps around. So it's when you multiply or divide by a negative number, you swap the direction of the inequality. Now, the reason we do that can be seen from the graph. If we're looking here, this is the graph of 6 minus 2x. You'll see that it's starting at 6 here as your y-intercept. And we're looking at where that is more than 1. And so where is this graph more than 1? Well, you can see it's at the 2.5, that when 6 minus 2x equals 1, that x equals 2.5. But where is it more than 1? It's when it's to the left of the 2.5. In other words, the x is greater. The x is less than the 2.5. When it's greater than 2.5, then obviously you've got it as less than 1. So if I want greater than 1, I want to be to the left of this. Okay, and so I want x less than 5 over 2. And this introduces an interesting thing to do with inequalities, is that if there's any doubts at all, always look at the graph, look at the sketch, and use that in order to decide on the inequality sign. Okay, so this particularly is going to happen when we now look at the next one, which is quadratic inequalities. Now, for a quadratic inequality, you're always going to want to do a sketch. So let's look at the first one, x squared minus 4x minus 12 less than or equal to 0. First thing, we want to find where it equals 0. And so what I do is I look at x squared minus 4x minus 12 equals 0. I change the inequality sign. Okay, now to solve that, it's easiest done by factorization. What numbers do I know that multiply to 12, and when we combine them it could come to a 4. It's going to be 6 and also 2, and so what you're going to have is plus 2 and minus 6. So it's x squared minus 6x plus 2x comes to the minus 4x, plus 2 times minus 6 comes to the minus 12. So we've got multiplying to the minus 12. Notice the order of the signs. Because it's minus 4x I want to end up with, I need to take away more, but I'm adding. So I'm taking away 6x, adding 2x to come to minus 4x. So if x plus 2 multiplied by x minus 6 equals 0, then either the x plus 2 is 0, and x would be minus 2, or the x minus 6 is 0, and x would be 6. So those are what are known as our critical values. Our critical values are where x is equal to minus 2 and x equals 6. But we need to find where this graph is less than or equal to 0. Now, to do that, we want to look at the graph. We need to sketch our graph of x squared minus 4x minus 12 and see where it is less than or equal to 0. Okay, well, what I've done here is I've cheated. I've actually printed off a copy of the actual graph, but you can see if you look at this, where is it that this graph here, this is x squared minus 4x minus 12, notice it's cutting, as we'd expect, at the minus 2 and the 6, and indeed, we could have sketched it. The graph, right way up, because it's a plus x squared, so the normal way up, and cutting 0 at x equals minus 2, cutting again at x equals 6. And what we're being asked is, we're being asked, when is this graph less than or equal to the 0? So we're looking at this bit here. So we want to use our sketch. if I push that out of the way, we want that bit of the sketch because we want where the graph is less than or equal to the x-axis. That's where it's going to be less than or equal to 0. And so you should see the x values here are in between the -2 and the 6. And the way that we write down that they're in between it is -2 is less than or equal to the x, which is less than or equal to the 6. So it's saying the -2 is less than or equal to the x, which is less than or equal to the 6. All set out in that one position like that. If we had wanted these bits here, then we'd have had to put down two things. We'd have had to put down one option as x as less than or equal to -2, and on this side we'd have had to put down the other option, which would be x is greater than or equal to 6. But as I say, we're looking in between, so it's -2 less than or equal to x, less than or equal to 6. Okay. Intersecting curves and lines. Now these problems can crop up whether you've got inequalities or not. Okay, so first of all we're asked find where the line y equals 2 minus 4x intersects the curve y equals x plus 2 times x minus 5, hence solve where the curve is greater than the line. Okay, so let's have a look at it. First thing, equate the terms to find where they intersect. So they intersect where the y coordinates are the same, so x plus 2 times x minus 5 must equal 2 minus 4x. Pretty obviously, to solve this, we're going to have to expand those and then rearrange the equation. So expand first. X squared minus 5x plus 2x is minus 3x minus 10. X squared minus 5x plus 2x comes to minus 3x minus 10. That equals 2 minus 4x. Now we need to rearrange it. So we move a minus 4x to the left, it becomes plus 4x. So you've got x squared minus 3x plus 4x is plus an x. And move a plus 2 across, it becomes minus 2, or minus 10 minus another 2 is minus 12. So that becomes plus 4x, so plus 4x minus 3x is plus x, minus 2. And you've already got minus 10, so it's minus 12. Right, so we're solving this. Well, factorizes easily. What do we know that multiplies to 12? But where you combine them, you might just get 1. It's going to be 3 and 4. Okay, we're adding more than we're taking away, so you're going to be adding the 4, take away the 3. Always check a factorization by expansion. X times x, x squared, minus 3x plus 4x is plus x, and plus 4 times minus 3 is minus 12. So, critical values, first of all, sorry, it says find where it intersects, so let's do that bit. Well, if x plus 4 is 0, x equals minus 4. If x minus 3 is 0, x is 3. So those are the two x values. But if I'm finding where it intersects, I don't just want the x values, okay, at the point of intersection, I also want the y values, the y coordinates. So I need to slot x equals minus 4 into one of these two equations. And the same thing for x equals 3. The much easiest one to slot it into is the first one. So if I put x equals minus 4 in here, okay, I get 2 minus 4 times minus 4. Well, minus 4 times minus 4 is plus 16. 2 plus 16, 18. If I put 3 in, 2 minus 4 times 3, well, 4 times 3 is 12. 2 minus 12 is minus 10. So my two sets of coordinates are minus 4, 18. That's that one. And 3 minus 10. That's that one. So we've got the coordinates, and now we're asked to solve where x plus 2 times x minus 5, that's the curve, is greater than the 2 minus 4x, the line. Okay, well, I could actually have done some alterations on here, but what I've done is I've sketched it out again as if you were having to do a sketch. And so you see it's the same sort of thing as here, but I put on two more key bits. I put on the x values at those 2 points of intersection. So that's where x is minus 4, that is where x is 3. And we want where the curve is more than the line. the curve has got to be greater than the line. So I want over here, do you see over here, the curve is above the line? So I want to be to the left of a -4. It is a strict inequality, so I mustn't have an equals there. Okay, so I want to be to the left of a -4. That is x is less than -4. And the other place is to the right of the 3, and that's where x is greater than 3. So my two options now, I've got x is less than -4 or x is greater than 3. I mustn't put an and here. I can put or, usually you just put a comma, so I just put a comma in. So x is less than -4 was one option, and the other option is x is greater than 3. Okay, let's do a couple of questions. First one, the diagram shows these two curves, y equals x squared plus 8x minus 20, and y equals minus x squared plus 3x minus 8. Find the values for which one of the curves is less than the other. Okay, well, the first thing we ought to have a look at is we need to find our critical values, and we also ought to know which curve's which. Well, this one, y equals plus an x squared, means it's the right way up, so that's the red curve, so that one's the red curve. Y equals minus x squared, that's the upside down one. Okay, and so that's a blue curve. So we're going to want where the red curve is below the blue curve. We're going to want this bit here. So we need to find our critical values, our starting bit. Instead of solving less than, we want, I've rearranged it first. What I've done is I want everything to do with 0. I could have put an equals in here first, let it equal and then solve, and then rearrange. In this case, I've rearranged first and then I'll put the equals. So let's rearrange it. X squared, the minus x squared moves across and becomes plus x squared, so I get plus 2x squared. 8x, that becomes minus 3x, so I'll be left with plus 5x. Minus 20, that becomes plus 8, so minus 20 plus 8 is minus 12. So I get 2x squared plus 5x minus 12 less than 0. That's what I'm trying to solve. Okay, so now we put it equals 0, and as I say, if you'd preferred, you could put let this equal this first, then do the rearrangement, and either way you end up with this. So I've got to factorize this one. Now notice no common factor other than 1, so I'm going to have a 2x and an x. Factors of 12 are 1 and 12, 2 and 6, 3 and 4, and we've got to decide which ones here could give me the 5. But we've got to be careful, because that's times 2x, that's times x. So you've got to try them both ways round. If I put the 1 there and the 12 there, I will get 24x and x. They can't come to 5x, but I should also try it the other way round. 2x, 12x also can't come to 5x. So that one's not worked, but I must try it both ways round. 2 and 6, let's try those. 12x and 2x can't work, can't come to 5. And there, 4x, 6x also can't come to 5. So let's hope that the last one works, otherwise we're not going to be able to factorize it. We'll have to use completing the square of the formula. Let's try it this way. 8x, 3x, that can come to 5. So that's going to work. If I had tried it the other way around, you'd see that it doesn't work. 6x and 4x don't work. They can't come to 5x. So I want it this way round. 8x, 3x. I want minus 12, so the signs are different. To multiply to minus 12. I want to be adding more than I'm taking away. Now, it's not a question of looking at the 4 and the 3. You need to look at the number of x's. That comes to 8x. That comes to 3x. I want to add more than I take away to get plus 5x. So I want to add the 8x. Sorry about that. And I want to take away the 3x. So let's check it by expansion. 2x squared plus 8x minus 3x is plus 5x. Minus 3 times plus 4 is minus 12. So when they equal 0, either the 2x minus 3 is 0, and if 2x minus 3 is 0, 2x equals 3, x equals 3 over 2. So for 2x equals 3, x is 3 divided by 2, or 1.5. or x plus 4 is 0, and that would be x equals minus 4. So there are our two critical values. So I now know on this sketch that this one is minus 4, and that one is 3 over 2. So if I look at the sketch, and I've done it here, okay, then these 2 points are minus 4 and 3 over 2. Now I can actually use this sketch here, or what I've done here is I've sketched this one here, because in order to solve this, all I have to do is to solve this bit. So to solve this one, I can say I want where that is less than 0. Less than 0 is this bit here, so that means I want between the minus 4 and the 3 over 2, so minus 4 less than x less than 3 over 2. Notice it's a strict inequality, so I'm looking at that there. 2x squared plus 5x minus 12 is less than 0 between minus 4 and 3 over 2. But alternatively, what I could have done is I could have said, let's look here. That's going to be minus 4, that's going to be 3 over 2. Where is the red curve, the one that's right way up, below, because it's less than the blue curve? Well, it's where it's in between the two, and in between the minus 4 and 3 over 2, it's this again, minus 4 less than x less than 3 over 2. So it doesn't matter which of the sketches I use. Right, next one. Now this is a very common type of question because it links in what you know about discriminants with solving quadratics. So we're told the equation 4x squared plus 2 lots of k plus 3 times x plus k plus 6 equals 0 has got real roots. Find the possible values of k. Right, now if we're doing this, we need to find the discriminant. So let's have a look at it. How many x squared? 4, so a is 4. How many x? 2 lots of k plus 3, and it's going to be easier if we actually expand this. So 2 lots of k plus 3 is 2k plus 6, and c is all of this, k plus 6. Okay, so there's our c. The discriminant is b squared minus 4ac. b squared, 2k plus 6, all squared. If you did leave it like this, you can do, but if you do, when you square it, you've got to square that too, as well as squaring the part in the brackets. Now, minus 4ac, minus 4 times a, that's there, times c, the k plus 6 there. Let's expand it. Well, expanding this one, what we do is an a plus b all squared, which is an a squared plus 2ab plus b squared. So it's this one squared, which is 4k squared, plus 2 lots of 2k times 6. Well, 2 times 2k times 6, 2 times 2k is 4k times 6 is 24k, plus the 6 squared, 36. So it's 4k squared plus 2 lots of 2k times 6, 24k, plus 6 times 6, 36. If you wanted to, you could have written out 2k plus 6 in brackets, and then another 2k plus 6 in brackets, and expanded it longhand. You'll get the same answer. Now, this one. Minus 4 times 4 is minus 16, so you're doing minus there. I've left the minus still in there, so I'm doing 16 times k, and 16 times 6 is 96. So 16k, 96, but notice I've still got that minus sign to deal with. So now, let's do it for the subtraction. 4k squared, onto the k squared there, so it is 4k squared. 24k minus 16k is plus 8k, plus 36 minus 96 is minus 60. So that's my discriminant. Right, it's real roots, you've got to be careful. If there are different real roots, distinct real roots, b squared minus 4ac is greater than 0. If there are equal real roots, identical roots, b squared minus 4ac equals 0. If you're just told it's got real roots, we're not told whether they're different or the same. So we've got to cater for both of those. We've got to have b squared minus 4ac greater than or equal to 0. So if they were different real roots, distinct ones, b squared minus 4ac would be greater than 0. If they're identical, b squared minus 4ac equals 0. If we don't know which, then it's greater than or equal to 0. So that's our inequality to solve. So we've got to solve 4k squared plus 8k minus 60 greater than or equal to 0. Factorise it. Oh, first of all, let it equal 0, then we'll factorise it. Well, 4 is a common factor. Whenever you're looking at factorisation, if you see a common factor, remove it. 4. So it's 4 times k squared plus 2k minus 15. Factorising this, well, multiplying to 15, and we've got to be able to combine them to get 2. So it's going to be 3 and 5. It's going to be different signs, k to get minus 15, and you're going to be adding more than you take away to get the plus 2k. So it's going to be plus 5 minus 3. I did that quite fast, but let's check this expansion. K times k, k squared, k times minus 3, minus 3k, plus 5k, so that does come to plus 2k, and minus 15. That comes to 0. So, 3 things multiplying to 0, one of them must be 0. Well, the 4 isn't, 4 is never 0, so it's got to be either the k plus 5 is 0, which gives you k equals minus 5, or the k minus 3 equals 0, which gives you k equals 3. So it's going to be one of those two. Okay, so let's go to our sketch, and what we're sketching is nothing to do with x's, we're sketching the k's. We're sketching this one here, 4k squared plus 8k minus 60, if you like, y equals that. And so if we do that, notice it's a plus for the k squared, so it's a normal way up. And notice you've got a minus 5 and 3 as your critical values, and we want where it is greater than or equal to. So it's going to be greater than or equal to is here and here. Those are the two places where you've got it greater than or equal to k. So it's got to be one of those two. So either the k is less than or equal to minus 5, or the k is to the right of that, greater than or equal to 3. Notice I've got to have an equals involved in these. So for sketching that, greater than or equal to 0 gives you k less than or equal to minus 5, or greater than or equal to 3. Okay, and so I hope that helps you. I think that's it, yes.